So far so good. Alright, so now we move on to a more complicated derived quantity. So force, momentum, pressure, energy or work, and then charge. For force, the symbol is capital F, momentum will be small p, pressure is capital P, energy or work, W for work, energy normally we use E, and then quantity of charge, Q. So these are the formula that you need to memorize. Okay, force equal to mass times acceleration, momentum is mass times velocity, pressure is force over area, energy is force times displacement, work force times displacement. Alright, and then charge will be current times time. Alright, formula for force is mass times acceleration. So now I'm using symbol F equal mass times acceleration. Okay, now we want to relate derived quantity force with the base quantity. Now, acceleration is still in derived quantity, so we change that. So, mass times acceleration. So, acceleration is actually velocity divided by time. Velocity here is actually displacement over time. Displacement is actually length. Alright, so we just substitute. So mass times velocity is length over time. Okay. But acceleration is velocity over time. So means that this divided by time. Divide by time. Right. So I try to explain slowly here. So just copy that. So length over time divide by time. Okay, like this. Now, we try to simplify it. So, mass, length, over time. Now, when you have this sign, okay, divide, so it can be changed to times, but this become like that. So, it become M, this is 1, this is 1, this is L. So, ML over T square. Now we relate force with the base quantity. So it becomes mass times length divided by time square. So from here, we can derive the base unit. So mass is in, the unit for mass is in kilogram. Alright, so L will be the length, which is in meter. And then T square is time, so divide by T square. Time is in second, second square. Alright, so now you can bring S2 up, so it becomes kg, ms, negative 2. Alright, so this is the unit, the SI unit for force, okay, kg, ms, negative 2. And the SI unit, okay, this kg, ms, negative 2 is the same as Newton. Alright, Newton. So which means 1 kg ms negative 2 is actually equal to 1 Newton. Okay? Hopefully you can understand this. Okay, next, momentum. So this one also you need to memorize the formula. Momentum equals to mass times velocity. So I'm using symbol again. So momentum is small p equal mass times velocity. Alright, so mass is already in base quantity. So velocity now is getting easier, which is displacement over time. Alright, so displacement is actually length. So I just use symbol L. Alright, so from here, now you see already that momentum, derived quantity, is the same as mass times length divided by time. So these are all in base quantity already. So when you are able to write like this, so it means that you already success to relate the base quantity with derived quantity. Alright, so from this, okay, you can derive the unit for the SI unit for momentum. So from here, we know that mass, okay, is kilogram. And then the length is in meter. And then time will be in second. So over second like that. So from here, can bring S up. So it becomes kg, m, s, negative 1. Okay? See, okay? Still remember the unit for force? So, unit for force is Newton. So, Newton is similar to kg, m, as negative 2. Okay, now, sometimes unit for momentum, if you look at other books, sometimes they write like this. So unit for momentum is Newton second. How is that possible? Alright, so we try to derive. So now you know already that Newton is kg m as negative 2. This is Newton, right? This is Newton. So just add in s behind times s here. Alright, so if let's say no number here, so it means that this is 1. 1. Right? So we simplify that. So equal to kg m s negative 2 plus 1. This is negative 1. Can see, right? They are the same. So that's why, okay, so we can say that unit for momentum is kg ms negative 1. At the same time, this is also correct, Newton second. Okay, interesting, right? Pressure equal to force over area. Still, I'm using symbol, capital P for pressure, capital F for force, capital A for area. Now, from here, substitute the formula. Force equal to mass times acceleration. Length, area is length times width. So that one is just like length square. Okay. Now, these are still in not in all not in base quantity. So need to convert acceleration. So equal to mass acceleration. From the previous slide, we know that acceleration is L over t square. This is acceleration divided by L square. Where I get this? Here. Right, so this is acceleration, L over t square. Okay, so from here, we try to simplify this. Yeah, right here. So equal, okay, mass length over t square. Now, all already in base quantity. It's just that we want to bring this up. Alright, so L2 bring up. Okay, it become, can do like this. This is another method. It become negative 2. Alright, so we try to simplify this. So it become M. This L is L1. Okay, L1, L negative 2, you times this, it will be 1 plus negative 2. So it will be L negative 1. And then you bring t square up, it becomes t negative 2. Alright, so this is the final formula for pressure. So it is mass divided by length divided by time square. So from here, you can derive the unit for pressure, which is M will be kilogram, length will be meter, so meter negative 1. Time is second negative 2. Okay, is it clear now? Or we can also write like this. So force is in Newton, area is meter square, so bring up the meter negative 2. So which means 1 Newton per meter square is the same as 1 kg m negative 1 s negative 2. Both correct. This unit is also the same as Pascal. So this is new Pascal. Pascal. So normally we use symbol PA, Pascal. So which means 1 Pascal is the same as 1 kg m negative 1 s negative 2 or 1 Newton per square meter. Work, the formula is times displacement. Displacement is similar to length. You can write like that. So force, okay, now we want to relate derived quantity work and the base quantity. So force equal to mass times acceleration, okay, times displacement. Alright, so we simplify this. So mass times, now you know already, acceleration is length over t square. And then now times length again outside. Alright, so we can simplify this. So we have ml square divided by t square. You can leave your answer like this. If you want to bring t square up, also correct. Okay, so from here we can, okay, let's say we bring t up. So it become ml square, and then t you bring up, then need to change. So it become -2. So from here you already relate work. Okay, you already relate work and its base quantity. And then we can write the SI unit. So mass is kilogram, M, mass kilogram, and then L will be meter length. Okay, put square on top. And then we have T. T is time, second. So put -2. Just copy that -2. Alright, so this is unit for work. So kg m2 s negative. So this kg m2 s -2 is actually equal to joule. We have another unit, joule, Joule, but the symbol is capital J. Don't use small j. So for the symbol we use capital J. So one joule will be equal to 1 kg m2 s -2. Another unit will be, is it, force is Newton, displacement is meter. Okay, force is Newton, so displacement is meter. So means that Newton meter. Okay, we try to convert. See, so Newton is kg m s -2. So this is from the previous lesson, previous slide. So put m behind. So now we can simplify this. It becomes kg m. So this is m2, and then just copy s -2. Can see they are the same. Isn't it fun? Okay, so we say 1 Newton meter is the same as 1 kg m2, okay, s -2 equal to 1 joule. Whenever work is done, energy will be gained. The unit for work is kg m2 s -2. So the unit for energy also the same. Okay, we try to prove whether energy has the same unit, okay, by looking at these two type of energy. I believe we have learned kinetic energy, and still remember or not the formula? So kinetic energy formula is half m v square. V is the velocity. Alright, so don't worry about half in front here. This one is a constant. It does not have unit. So we just look at the physical quantity, which is mass and velocity. Alright, so mass and velocity. So unit for mass is kilogram. Unit for velocity is meter second -1. Don't forget here 2, so need to bracket. The unit for velocity, you put square outside. Alright, so here we simplify this. It becomes kg m2. Okay, open the bracket. So s also times 2, so -2. Isn't they have the same unit? So kg m2 s -2. Now we see gravitational potential energy. So formula for gravitational potential energy is mgh, right? So m is mass, so unit for mass is kilogram. G is actually gravitational field strength, or we can say this is the gravitational acceleration. So the unit for G is the same as acceleration, which is ms -2. And then h is height. So height unit is unit of length, which is meter. Alright, so we combine all, it becomes kg m here, so this is m2, and then s -2. You see, kg m2 s -2, kg m2 s -2. So up here also kg m2 s -2. So we prove that all type of energy actually have same unit, which is same unit as work done. Isn't it interesting? Okay, we recap. So density, the formula is rho equal to mass over volume. So this is how we write the symbol rho. Rho equal to mass over volume. Okay, capital V. And then you know that the unit for density is kg m negative 3. Okay, actually you can derive the formula sometime from the unit. So this is the unit for density. So you see kg is mass, m3 is actually length. Alright, so negative 3, if you bring negative 3 down, it becomes m over l positive 3. So L positive 3 is actually volume. So means that mass over volume. So from here, you know the formula for density is mass over volume. If you still remember force, the unit for force is Newton or kgm as negative 2. So kg is mass. M negative 2 is acceleration. So here you know that the formula for force is F equal ma. Isn't it interesting? Subhanallah. If you understand this, please comment below. Give some feedback so that I know how to improve. Okay, all the best. We look at SPM 2019, Paper 2, Section A, question number 1. So diagram 1 shows a container of chocolate-flavored ice cream. So there is a label showing several physical quantities on the container. Alright, so look at the container. So you can see here serving size, 1 scoop, mass. Mass is a physical quantity. And then keep frozen at temperature. So temperature also a physical quantity. Volume in the container. So we have 3 physical quantity label on the container of the ice cream. Alright, so physical quantities can be classified as base quantity and derived quantity. So the first question, what is the meaning of base quantity? Okay, what is the keyword? So just write the quantity that cannot be derived from other physical quantity. Okay, quantity that cannot be derived from other physical quantity. That is the answer. Okay, next. So based on diagram 1, classify all physical quantities into table 1. So we have 2 base quantities, derived quantity. Okay, look at the diagram again. So we have mass, temperature, volume. Mass, temperature, volume. So which one is base quantity? Mass. What about temperature? Temperature also is the base quantity. So right here, temperature. What about volume? So volume can be derived from other physical quantity. So it will be under derived quantity. Okay, so this is mark 1, both correct. And then this is mark 2. So the total is 2 marks. Alright, next. So the symbol M in 1500 ml is a prefix. So state the value of M. Okay, now before this we know M stand for mass. M also stand for meter. Now what is this M? I believe you have learned this in lower form. M here is actually milli. Okay, so they ask you the value of M. You need to write times 10 negative 3. Okay, so you can write 1 in front here. Okay, so 1 times 10 negative 3. So this is milli. Okay, so this is 1 mark. We use physical quantity in our daily life. One of it is for the world record. Example, the fastest man on earth in 2019, the biggest mass animal, and then the tallest man. Okay, so they have the numerical value Okay, just like this, Usain Bolt can run 100 meter in 9.58 seconds. The mass of the blue whale is around 50,000 to 180,000 kilogram. That is huge mass. And the tallest man is Sultan Hussein, 251 centimeter, which is equal to 2.51 meter. Physical quantity also used in our daily life applications, such as in scientific investigation, international businesses, and also trading, plantation, and cooking. So when we have standard physical quantity measurement, so it is easy for people all around the world to share knowledge, to exchange the knowledge. Example, let's say you want to cook, so even in recipe also we have standard unit. Okay, in plantation, the mass, if let's say you want to sell crops, okay, so we look at the mass, and the mass 1 kg in Malaysia will be the same as 1 kg in Japan, will be the same as 1 kg in USA. In scientific investigation, example, let's say scientists discover the smallest creature on earth, so they can exchange the information, okay, and the other scientists from the other part of the world can visualize how small is that creature by looking at the numerical value and the standard unit. Okay, so summary, let us recap. Hopefully, you can define physical quantity, base quantity, derived quantity. So remember, physical quantity are the quantity that can be measured. Base quantity are the quantity that cannot be derived from other physical quantity. Derived quantity are the quantity that can be derived from other base quantity by multiplication, division, or both. Okay, list out base quantities and derived quantities. So you have learned 7 base quantity, which is length, mass, time, thermodynamic temperature, electric current, luminous intensity, and amount of substance. And then make sure you know some of the derived quantity, example, force, momentum, pressure, energy, and so on. And make sure you know also how to write the unit. And then we already succeed in relating the base quantities to derived quantity, and then solve problem, and also looking at some application in our daily life. Finally, we have come to the end of this lesson. If you stayed until this part of the video, please comment down below 3 red heart emoji like this. Thank you so much. Till we meet again, insyaAllah. Assalamualaikum warahmatullahi wabarakatuh.